I am Jacob Barnett, here to discuss some topics from Calculus 2. Most people like to do back of the envelope calculations, but what I'm about to do is not going to be the size of a typical envelope, so I'm going to do back of the house calculations. I am using my back window. My dog Igor is outside right now, so you might see him wandering around. He's right over there behind the fence. Kind of hard to see from right now, but he'll walk over. So we have Igor, we have the window, and we have the back of the house calculations. Now, instead of using my whiteboard, I'm going to use this because my whiteboard's got a bunch of theories on it. So today we're going to do techniques of integration. We're going to do integration by parts. And then later we'll do trig substitutions, trig integrals, and partial fractions. So let's start with integration by parts. And don't worry, I am here to help you with all your math phobias. So we have integration by parts. I can go back to calculus 1 and say d by dx of f of x times g of x equals f of x times g prime of x plus f prime of x g of x. I can take the integral of both sides, so I get f of x times g of x equals integral f of x g prime of x dx plus integral f prime of x g of x dx. I subtract this integral from the other side, so then I can get the integral of f of x times g prime of x dx equals f of x g of x minus integral of f prime of x g of x dx. So this is what we call integration by parts. Now, this is really long, so Leibniz introduced a new terminology. He said we call one function u. That's not a u, that's okay. So there we have our one function being u, and our next function is dv. And then this becomes f of x, and this becomes g prime of x in our equation. So then we can replace this with integral of u dv equals f of x g of x minus integral f prime of x g of, I'm supposed to be putting this in the uv term. Sorry. I go to my uv term, I call this uv, minus integral of u prime, du times v, which is often called v du. So this is a lot less messy. So we often use this terminology. This is good for, I'm going to use a couple of samples of integrals which we won't be able to solve from u substitution, but we can if we use this terminology. So first we're going to take the integral of x times the cosine of x dx. Now this is fairly straightforward. We try to find a u and a dv such that this integral becomes simpler. So if I have u here, then I end up with a du in this integral. So I can make this du be 1 if I make x u. So I'm going to call x u, and then cosine x equals dv. Well, cosine x dx. So then I have du equals, I will have dx. Now, the reason I'm throwing in these dx's at the end of these terms, it's just for making this integral a little bit easier to understand, because here we would originally have du by dx equals 1, and then dv by dx equals cosine x, so I'm just multiplying to the other side. So then here I have v equals the integral of the cosine x, which is the sine x, dx. I mean, no more dx. Dx goes away. So now we have that. I can now simplify this. We have the integral of cosine x dx equals u times v. So this is x sine x minus integral of v du, which is sine x times dx. This ends up being x sine x minus cosine x. Let me just check my work. I used an example from the book. Yep, that's it. Okay, and then we also have plus constant of integration. So that's how we would solve an integral like that. Okay, so are you seeing how to do this? We can take the next integral of natural logarithm of x dx. This is my next integral. Now for here, we don't really have much of a choice, because let's say I call u dx. Then du, it's not really anything simple. So I'm going to call dv dx, dv equal dx, and then I say u equals natural logarithm of x. So then I have du equals 1 divided by x. And then I have v equals x. So now I have uv, which is this one times this one, x natural logarithm of x minus integral x, forgot my dx, times 1 by x dx. This equals, I'm going to put a little slashing mark so you don't get that confused, x natural logarithm of x minus integral of dx. Integral of dx, as you should know, is x. This equals x natural logarithm of x minus x. That's how you would do something like that. So integration by parts, it's going to make, if I have two different integrals, really easy to do. So now, I am going to take the case where I have the integral of x times e to the x dx. Oh, forgot a plus c. Always remember to put in your plus c, otherwise you'll lose like a point on a quiz or something. So you got integral x times e to the x dx. Well, e to the x squared. E to the x is pretty straightforward. So I can remember our u substitution, and instead of having to do integration by parts, I have du by dx equals, I make u equal to x squared. Du by dx equals x. Then dx equals du divided by x. I can just factor some stuff out. And this, forgot a 2. So this becomes du divided by 2x. This becomes 1/2 integral of e to the u du. I could have done integration by parts for x e to the x squared, but it's easier to do u substitution, so always watch out for u substitution. You can do integration by parts in a lot of scenarios, but you might want to watch out for this u substitution. Okay, so I'm going to finish this integral, and then we will continue on with trigonometric integrals next time. This integral becomes 1/2 e to the u plus c, very obviously. This becomes 1/2 e to the x squared plus c. Thank you for watching. I am going to do trigonometric integrals next time.